Hello everyone, it's me Tabo and welcome to another episode of Coding for Superheroes. If you are new to the channel, be sure to subscribe and make sure that you hit that like button. I appreciate it a lot and it really helps me grow. And last but not least, make sure that you hit the notification bell so that you don't miss out on upcoming tutorials. In today's lesson, we're going to pick up from where we left off. If you did not watch the previous tutorial, I suggest that you do, because everything that I am going to be teaching here is going to be based off of that lesson, and I am literally continuing from where I left off. In the description, I will leave a link to that tutorial, and I will also leave a link to a template for this code. So in today's lesson, we are going to be learning about constraints, kinematic bodies, interactions through mouse clicks, moving rigid bodies with key inputs. To demonstrate the things that we're going to be learning, I've got an example right in front of me. This is a hinge. These are the constraints that you will be learning about. This over here is a slider, but I will not be explaining all of that right now. I'm just showing you a little demo just so that you know what is going to be in store. This is a kinematic body that is being controlled with key inputs. And this is a rigid body, an active rigid body, which is also being controlled using key inputs. So you've got all of these working together. And over here, I've also got force that I'm also applying through mouse click. So this is what our lesson is going to be based on. So without wasting a lot of time, let's just jump right in. So in front of me, I've got the previous code that we were working from. So just so that you remember, or I'll just do a quick refresher. This is what that scene looks like. So this is from the current code that's in front of me. We learned how to create a block, which is the surface on which all the rigid bodies are falling. Then we created several rigid bodies. We created a ball, a box, cylinder, and a cone. And in here, we've got our start function. This is where we are calling all of these. And over here, we've got our global variables. In here, we've got our set physics. Then we've got set graphics, which is where all of our Threejs code is. Some of the things that I mentioned earlier that I made a few changes, I'm just going to highlight them just for those that might be using the old code. In here, I added a window resizer function. So I just will be resizing that every time I make changes to my window. I also made changes to the light. So over here, check P light. I made changes to the intensity, the position. This one might be the same, but just make sure that everything matches. I also added names to the meshes. Previously, I did not do so. You can see they're all named. This is mainly for debugging purposes, so that if something is not working as it should, then I can easily locate these objects. That is about it. Everything else is just as it was in our previous tutorial. The first thing I'm going to do in this lesson is include all the global variables that I will need for this entire lesson. All right, underneath here, I will paste our global variables. You can do the same if you want to stay a bit organized so that you can know what was what. But this is mainly also for me so that I can also keep track of what is new and what is not. So just look at all of these variables. Just make sure that you also have the same variables. It's quite a lot, but every time I use any of these variables, I will come back and refer to it so that you understand where it's coming from, so that you don't get confused along the line. Moving on, the first thing I will do is create the mouse interaction. So I will set up the project so that we can have mouse inputs. The reason why I'm doing that is because most of the interactions will be through the mouse. I will be demonstrating me applying forces to the different rigid bodies. So that will be the first thing that I will do, and then everything else will be built on top of that. Inside of our set graphics function, just underneath where I position the lights, here I will paste this function mouse move. Now these are not in order, but everything that I'm doing, I will explain it so that it all ties up and makes sense. So this is one of the functions that we will need. We will need to create a function called mouse move. and we'll pass it the event. So this is the function that's going to be called every time we're moving our mouse. We'll set the event to prevent default, and inside of here we've got an object called mouse. This object comes from one of the new global variables that I've just pasted. It's over here. So we've got this variable which is equal to vector2. So this will be holding the coordinates of our mouse, the x and y coordinates. So in here I will say mouse.x equals to event.clientx divided by window.innerWidth times 2 minus 1. Mouse.y equals to minus event.clientY divided by window.innerHeight times 2 plus 1. Inside here you can see this function that is being called. It's called intersection. Might not make sense, but we are going to also create a function called intersection as well. The next function I will create is called add selected object. Now add selected object will take an argument of object. Basically, this is a function that is going to be managing the selected objects. It will be removing old selected objects and putting new ones. Selected object is an array that is holding the selected objects. So we will check it to see if its length is bigger than 0. If it is, then we will remove whichever object is currently there, and then we will put in a new one. That's all that it is doing. Then next we will create an intersection function. Now inside of intersection, we're going to set our array casters, set camera to mouse and camera. If you're wondering where this is coming from, it's over here. Over here, we created a variable called raycaster, and it is equals to new3.raycaster. Inside here, we're setting its camera. So we're going to give it the mouse object, and then we're going to also pass the camera. Then we create a variable called intersect. Intersect is equal to the intersected objects. Intersect will be equal to an array which will be holding the objects which have been intersected. And inside of intersect objects, we're going to pass interactables, and we're going to set this to false. What is interactables? Interactables is a variable in our global arrays. This variable is an array. So this array is going to be holding all of our meshes. So all the objects that are going to be visible in the scene that we will be interacting with will be inside this array called interactables. In here we create an if statement, and then we will check the following condition. Intersects.length, if it is bigger than 0, then we're also then gonna do another check. Then we'll say if intersected is not equal to intersects.object. Basically we're checking if intersected is not equal to the previous object. So if that is not the case, then we will check if this object is of type mesh, and if that is true, then we will then say intersected is now equal to this new object that we just intersected. And then after that, we will add that to selected object. So we will add this intersected object to our function over here. This is this function over here. This is just the cleanup function, just to remove and replace old objects with new ones. Then just for debug purposes, I'm just consoling here just to make sure that everything works well. So if this fails, then we're just simply gonna set intersected to null. All right, so we've got our mouse move, we've got this, and we've got that. So the other two things that we're gonna need is then push the relevant objects into our interactables array, and then we will also need to set up the event listeners to call some of these functions, the mouse move for instance. And last but not least, we also need to create a mouse click function. So outside of our set graphics function, we're going to create a function called on mouse click. Here we go. This is our function on mouse click. In here we create a variable called velocity, and velocity will be equal to new ammo.bt vector3. Inside here we're going to pass it the direction of our array. Raycaster.ray.direction.x, raycaster.ray.direction.y, raycaster.ray.direction.z. Then next we create a variable called origin, and inside of origin we're also gonna pass it the origin of our raycaster. The origin is just the position. So from which position are we going to be shooting our ray? So we're gonna pass it these values over here. Next, create a force factor variable which is equal to 10. Then we're going to use this force factor to multiply our velocity. So velocity.op underscore mole, then force factor. We're just basically multiplying this velocity over here of our direction. Next, we create an if statement, and then we will check if intersected is equal to null. If it is not, then we will make these various checks. So for this particular start, I will just comment out some of these. They will only make sense later. One of the rigid bodies that I will be creating, or one of the constraints I will be creating, is hinge. So that's what that's going to be checking. But by default, it's just going to fall to this one. So the first rigid bodies that I will be applying force to will be implemented here. So all we're going to do is check if this is null, and if it is not, then it will just go to our rigid body. So it's inside our user data physics body. Then we will set linear velocity using this velocity that we created over here. Simply. So that's what mouse click will be doing. Next, I will go to the individual functions that are creating our rigid bodies and our meshes, and I will put each one of them into our interactables array. I'll say interactables dot push, and then in here I will push ball. I will do the same for all the other objects. So under here I'll just say interactables and then a box. Let's do the same for our cylinder, the cone object. Great. Now that is sorted. Next, we will deal with the event listeners. We need to create event listeners for the functions that we created. So for our on mouse click, we will create an event listener inside of our start function. So in here, we will create this event listener, and then it will call mouse click. So on mouse down, we'll just call our mouse click. The next one will be in our set graphics function. We need to create an event listener for mouse move. I will just put it over here. So underneath the event listener for our resize, I will also paste this one over here. So renderer.dom element.event listener mouse move. It will call our mouse move function. All right, so after having done all of that, let's run our server and check if everything is working as expected. So here I am, I'm just gonna refresh. When I click on the objects, right, there is force that is being applied. So this is working. Let's check if there are any errors. So far no errors. All right, so this part of the lesson is covered. So now we have mouse inputs. Now next, I'm just going to do one simple thing. For these three objects, I'm just going to increase their number. Okay, this is just to have more objects to play with in the scene. So I'm just gonna create a for loop, and then I'm just gonna then loop 4 times. So we'll just loop 4 times and create these objects. So that's all that's gonna do. Awesome. Now we have more objects to play with. Next, we can start creating our constraints. The first constraint we're gonna start with is point-to-point constraint. So here under the create cone function, I'm going to paste our new function. This function is called create joint object 1. If you can remember anything from the previous lesson, most of this is the same. So we just create a position object, and since we're going to be using 2 bodies here, we're creating 2 position objects. We're going to create a radius, scale, quaternion, a mass 1 and mass 2. Mass 1 equals 0 and mass 2 equals 2. We're going to assign each body a different mass. Mass 1 makes it static, so it will not be influenced by gravity. And then the second one is the one that will be influenced by gravity and all the other forces. So this will be created using a sphere. After creating it, we add it to our interactables array. We push it in there, and then we're going to set the position of it. We're going to make it cast a shadow. We're going to make it receive a shadow, and then we add it to the scene. I'm just going to move this over here. I prefer doing it this way. All right, so next we create a transform. This is an Ammojs transform object. We set the identity, we set the origin. The origin is the position, and that's going to be receiving position 1. So from our position 1 object, we're going to pass it all the relevant values. And then this is our rotation. This is derived from our Ammojs quaternion, and we're going to also give it the values from our quaternion over here. So all of this stuff is the same. I'm just doing this so that this is some kind of revision, but I will probably only do it once, and I will only focus on the new material, which is the constraints, how you set up a constraint for a rigid body. Then we create our motion state, and we will pass it the transform. After that, we create a shape, a sphere shape. In this case, we give it a margin. We're going to use also the radius for its size. We create local inertia, which is just a vector3 object. Then we're going to pass that inertia to our calculate inertia. We pass it mass and local inertia. The RB info, rigid body info, this is just the construction info. It's mass, motion state, sphere, collision shape, local inertia. And then the sphere body is the rigid body. So we create a rigid body, and then we pass it this information. Then we pass the rigid body into our physics world. Okay, here is the rigid body. Over here, we are setting the collision masking. So we are saying that sphere body belongs to this group, which is called group green ball. This name doesn't really mean anything. You can call it whatever you like, but it belongs to this group, and it will be colliding with that group. That's what that means. Then next we create another geometry block or another mesh. So this will be a box geometry. Same story over here. Nothing new is happening. So we're going to repeat the same process. So I want to get to this part over here. Okay, this is the interesting part. Once all of that is done, you've created your rigid body. Then we're going to come here. We're going to create two variables, one called sphere pivot. It is an Ammojs vector3 object. Then the next one is block pivot. It is also a vector3 object. This is where we are placing the pivot. The pivot is the place where the joint is going to be. So if you have two bodies that are going to be joined together, the center of the joint, this is what this means. So if you think of just a regular mesh which has its origin in the center point of the mesh, think of that as the pivot. So you're taking that point and you're moving it to the position where you want the rigid body to be centered. So in this case, I'm using these values, which mean that on the X, it's not going to be moving. So it will stay at 0 position. And our radius, it's going to say minus radius. Now we are using a sphere. The sphere is the one that is going to be at the top, and underneath the sphere, the box will be hanging. So we're just saying just on the edge, just where the sphere ends on that radius, this is where we want the joint to be. So that's why here we're saying minus radius, which is minus 2, right? Because the radius of our sphere is 2. So minus 2 means you're going 2 units below. That's where our point is going to be on the Y position, and on the Z position, we remain at 0. Same with our block pivot. This is for our box, right? If we look at the scale of the box, on the Y-axis, it is 5, right? So meaning that since the scale is 5, it is 2.5 and 2.5 on each side. So if you want to move it up, it means if you want to move the pivot up, which is at 0 point, we would have to move it up 2.5 units to the top. So that's what that pivot means, or this is what this basically means. So on the X and on the Z position, it's going to remain at 0. And then after that, we create a BT point-to-point constraint. We're going to call it P2P. And then inside here, we pass it the sphere body. That's the rigid body for our sphere. We pass it the block body. That's the rigid body for our box mesh or box rigid body. Next, we're going to pass it then these values that we created here are sphere pivot and block pivot. Once we're done, then we're going to say physics world.add constraint P2P, and then we're going to set that false or true. To be honest, at the moment, the result is the same. So now that that is done, we're going to then call our function inside of the start function. So let us say, what is it called again? Create joint objects. Yes. All right. So we're going to call our function, create our constraints, and let's see. Great. So there we go. As you can see, we've got our sphere, and right here, this is where the pivots are, both pivots. So at the moment, our joint is not doing anything, but if I click on it, then I apply force to it, then it starts swinging. So now we've got our first constraint. So now we're going to carry on and create more. Now in this example, I used 2 bodies. It is also possible to create a point-to-point constraint with just 1 body. So the next one will just be that. But the process is the same. The only difference is that you will just be using 2 values, which is your rigid body and your 1 pivot, because you only need 1. So I'll create this one as well, and I will call that create constraint object. So this is a single object. I will be creating that with a box geometry, and everything else is the same. Nothing new there to explain. The only difference is over here. As you remember, last time we had 2 pivots, and I still have this one. This is just because I copied and pasted and just made changes to that one, but we've got our block pivot. So we're going to use our block body and block pivot, but pretty much everything else is the same. All right. So let's see what that is looking like. All right, great. So now we've got 2. So now they're swinging. So next, I'm going to create a third one that is just for show. I'm going to be using different shapes for this one. So that was also partly the reason that you can create these constraints for different objects of different shapes. All right, I named this one create joint objects 2. This time I'm using a cylinder and a cone. All right. So everything else is the same. So I'm not going to explain anything. I'm just going to quickly do this so that we can move on to the other types of constraints. All right. So you can see, I mean, when I first saw this, I thought of a bell. You know, you can ring a bell this way. This would be, I guess, an interaction that you can consider, but obviously it's got to be more than that. So there we go. So now we've got our point-to-point constraint. The next one will be a hinge. Now for a hinge, I'm going to create something that looks like a door. So underneath our previous constraint objects, I will be creating our hinge, create hinge object function. In here, it's similar. So all these parts I will be skipping because there's nothing new to learn here. So we'll come to this part. So this is how you set up a hinge constraint. You need a rigid body, and well, you need 2 rigid bodies, and then you need a hinge position 1 and 2, and then you need axis, and then we'll set this to true or false. Either way, it works the same. All right. So I will start explaining. Over here, I created 2 vector 3 objects, hinge pos 1 and hinge pos 2. Then over here, I created an axis. The axis is where you want your rotation to be. So in this case, it will be on the y-axis. Okay, so that's what that is. And then the hinge position, it's similar to the pivot. It works the same way as the pivot. This is where the rotation is going to be happening, and the point where the rotation is going to be happening. And then this is setting the rotation limit. Okay, how far it you want your rotation to be? Do you want it to keep rotating round and round, or do you want it to only go 90 degrees? So that's what that is. And here I've got these values, which it's just for example. I will not be using them inside of this function, but I will explain later what these are doing. I will actually illustrate what that is going to be doing. So for now, I'm just going to stick to this. So that's what I need to create our hinge. Once again, it's 2 rigid bodies, 2 positions, and 2 axes. I mean, for the axes, in this case, it's just the same axes. I don't really need anything more. And I will also say, just I tried creating a hinge with only 1 body, and it was not working. The rigid body was disappearing. Okay, so then I just reverted to this one, which is still fine. There's not really a problem, but like the point-to-point constraint, which can also be created with just 1 rigid body, yes, it was supposed to work the same way, but for whatever reason, it was not. And I Googled and did all the necessary research, but there was nothing. So I only have this one example for the hinge constraint. So after that, then we will add it to our physics world through add constraint. Then we'll say hinge, and then we'll also make that true. So now let's go and initialize it. Here is our hinge constraint. So as you can see, it's like a door-like thing. So this is the part that won't be moving, and this is the part that's supposed to be moving. So when I apply force to it, so that's what happens. Now I will come back to a part of the code that I pointed out earlier, but now I need to put more emphasis to it. It is in our, is it the mouse click? Yes, over here. Remember last time I said this is not important. Well, now it is, because now we're in this part of the lesson. So over here, I'm checking to see if the rigid body that I am interacting with is hinge. If it's a hinge, then this is what I will do to it. I'm applying or enabling the angular motor. I'm setting it to true, and then this is these are the values that I was talking about earlier. The velocity, this is a velocity, and this is the, I forgot what it's called. Let me just go back down. It's these values over here. Okay, it's the target velocity, the maximum motor impulse, and then so these are the values that I have set inside that enable motor over here. So that's pretty much what that is doing. If I turn that off, what will happen is that it will keep spinning over and over again. Okay, I have to turn that off. And another thing also that I need to remember, yes, I think what happened is that when I set the limit, no, actually when I set the limit, it doesn't actually work. Okay, it still kind of moves like 360 degrees. So this is what that, so now if I do this, it just keeps on rotating. So the enable motor, this method over here, this is what controls that, because only when this is called, then the limits that I have set over here, only then they apply. So that's what that is doing. So yeah, we can see that our hinge is working. So I can, well, next time when I refresh, it's gonna be working as it should. So far we've got some cool and interesting constraints happening. So the next one is going to be a slider. Okay, we're going to create a slider constraint. Now that one was also a bit complicated. It was complicated to create. I had to really do a lot of research to find out how it works or how to get it to work properly. But it's working now. All right, so the next function is called create slider constraint. So we're gonna skip the boring parts. For this slider, I'm gonna be using 2 blocks. It's just gonna be 2 blocks. Then we're gonna get down to this part over here. So here we say we create a variable called slider. Now these variables are from the global variables over here. Okay, so every time you wonder where a variable is coming from when you didn't see me create that variable, just know that it's from our global variables that I pasted at the beginning of the lesson. So here we say slider equals to new ammo bt slider constraint. We pass it a rigid body, 2 rigid bodies. Then over here we pass it a new ammo bt transform. Try different ways of doing this, and with some of them the results were slightly different. So for this lesson I'm going with this way, but there are kind of other ways that you could set this up as well, but there are some complications. So in here, we create a new Ammojs transform, and inside we pass it the quaternion. Over here, I created these variables. This is slider position 1 and 2, slider quaternion 1 and 2. Okay, so these are the values that I'm going to be using to pass into our BT transform. This is similar to saying a transform.set origin, transform.set rotation. It's same thing, even though when I did it that way, but ultimately that's what that means. So we're going to pass it the quaternion and the slider position, and then we're going to set that to true. Once we've done that, then we're going to set the slider limits. We're going to set lower linear limit to -2. Then we're going to set the upper linear limit to 2.0. And the positioning, this one, yes, I have to actually make a drawing of this in order for it to make sense, because it's slightly different. All right, over here we've got two boxes. The pivot for the other one is 0. I set it to 0, so it's over here. The other one, I'm just going to give a color, different color. The other one is -3. Now what that pivot means is just, it says from here, this thing is going to slide all the way till this point. So from that point up till its limit, that is going to be -3. Okay, so it can slide, and this point would be then the edge of this one over here. So if it slides all the way here, it would be sitting somewhere here. Let me just, okay. So if you can understand that this is the one that's going to be sliding, and then that one is going to be still. That's the one that's going to be static. So the pivot for that one is over here, and this one, so it means it has a range of -3 from where it is, because in its position from where it is, we're counting this way. Okay, so from this position, we say -1, -2, -3. That is the range that it's going to be sliding. So just to kind of make sure that you understand that. Okay, enough with that. All right, so now I've set the lower limit to linear limit to -2 and the slide upper limit to so. So this is the range that is going to be sliding. Okay, so now let's call our function. All right, here we go. So this is our slider constraint. As you can see, I'm applying force from only this side, because if I do that, then nothing's gonna happen. If I do this, like, nothing's gonna happen because it's only moving in the x-axis. So yeah, that's how our slider constraint works. So think of a drawer. You know, this is how you would control the sliding in and out of a drawer. So you can think of many other examples that you can use it for, but that's pretty much how you set that up. So the next thing that we're going to be doing is a controller for two rigid bodies. One active rigid body, which is a ball, and one kinematic rigid body, which will be a box object. A kinematic rigid body is a body which is not influenced by gravity or any other forces. And that would work well for a character controller, because you can then drive the rigid body using your mesh. So that could be a way that you are colliding with other objects, but you can only act upon other rigid bodies, but they do not have any effect on you, you know. So that's the difference. And then an active rigid body is just another rigid body that, like these ones, these are active rigid bodies, but the difference is that this one will be controlled using key inputs. Okay, your WASD key inputs. So that's what we're going to be creating next. So we're going to start with the ball and then next do the kinematic rigid body. All right, so under the set graphics function, I will create a function called keyboard events. Inside of keyboard events, I will create an event called onKeyDown, and onKeyDown will be calling handle key down. Now this function is not yet created. I am about to create that next. and we create another event called onKeyUp, and onKeyUp will be calling a function called handleKeyUp. Our first function will be handleKeyDown. Now handleKeyDown will be receiving an event argument, and in here we're gonna create a variable called keyCode, and keyCode will be equal to event.keyCode. We create a switch statement, and in here we're checking the value of our keyCode, and according to the value, then we will then make the value of move direction.forward equal to 1. Now if you're wondering what move direction.forward is, in our global variables we created an object called move direction, and we also have another one called k move direction. This is what we're going to be using for our kinematic object, but currently we are using this one. Our object has these properties: forward, back, right, and left. So these are the properties we're going to be using to control the X and Z movements of our object. You can think of them as characters, I guess. So that's what's going to be happening here. So 87 will be equal to like a forward movement. So move direction.forward will be equal to 1. So the same thing for back. So as long as it's onKeyDown, it will be setting whatever key has been called here to 1. If you can notice over here, I'm also already calling the k move direction. So pretty much I'm setting up all of that in here, even though my focus at the moment is on the ball, but just pay attention that this is also being done, but I will come back. So that's all I'm going to be doing in here. So we're going to be calling the next function, which is handleKeyUp. Now handleKeyUp will be doing the opposite. It will be setting the property to 0. Okay, so 0 would mean no movement. So only when the key is down, we'll get movement. When it's up, there will be no movement in the relative direction. So that is all that is doing. Then next we will create a function called moveBall. Alright, so here is our function moveBall. Inside here we create a variable called scaling factor, which is equal to 20. We create a variable called moveX. MoveX will be equal to move direction.right minus move direction.left. MoveZ will equal to move direction.back minus move direction.forward. So how that would work is just controlling the different directions that it would go. For instance, if move direction was equal to 1 and move direction left was equal to 0, then 1 minus 0 would just be equal to 1. And if move direction.right was 0 and this was 1, then it would be 0 minus 1, which would make it equal to minus 1. So it would then move to in the opposite direction. Oh, move Y, we can use it for jump, but in this case, no, I'm not going to be using it for anything. So here I will be checking if move X equals to 0 and move Y equals to 0 and move Z equals to 0, then return. Okay, so if any of these are 0, there's no need to be doing any of that. But if they are not, then we create a variable called resultant impulse. It will be equal to new ammo.bt vector3, and inside we will pass it the relevant properties. Resultant impulse will be multiplied by scaling factor. And then here we'll create a variable called physics body. This will be equal to our rigid body. And then we will then set a linear velocity to our rigid body using a resultant impulse. Inside of our render function, I will call moveBall. Inside of our start function, I will call keyboard events. Alright, I just got an error which said that ball object does not have user data dot physics body, which is correct. If you go to the create ball function over here where we're declaring a ball, we can also say ball object equals to, so put ball object over here. So just say let ball equal to ball object, which is equal to that. So everything that we're doing here, it will also be here. Okay, so that's all that we need to do. And since that's the case here, it's probably also the case with, well, when I create the kinematic box, I will also have to do the same thing. All right, so anyway, that's that. So let me check again to see if the error persists. All right then, so everything is working. So here is our ball. So now we've got an active rigid body, which is being controlled with our keyboard inputs, wizard, like I call it. All right, so now we've got that working. Okay, cool. So everything is working as it should. No problemo. So let's move on to the next one. So next we are creating our kinematic rigid body. All right, I'm just gonna place it under here under ball, but it doesn't really matter where you place it. So our next function is called create kinematic box. The way we create a kinematic box is no different to any other rigid body. The only difference here is over here, collision flags. Okay, body.set collision flags, flags.cf kinematic. Okay, I've created an object over here. So this just makes the flags equal to that. There are like different flags that you can use for your rigid body. You can use also static. All right, over here, I've got a list of the different flags that you can use. Right now, we're using this one over here. So you can choose whichever one is appropriate for your needs. Static is basically when there's nothing happening, no animation, no movement or anything. That's the one thing that is different. And the other thing is these values over here. Now, these are values that you can set, but in this lesson, I'm not going to be talking about that so much. We will incorporate these things in coming lessons, but in this particular lesson, I'm just going to cover the things that I mentioned, and everything else I will do later. Anyway, so I'm just going to comment it out. All right, so that I've set that to kinematic, and that's the only difference. Okay, so all right, there we go. So the next function, it's called, well, move kinematic, not kinematic box. But anyway, in here we create a scaling factor of 0.3. We do the same thing as the other. Move x equals to move direction dot right minus k move direction dot left. Well, same old. Then the translation here, the translation factor will be equal to tmp pause.set. So if you're wondering where tm pause comes from, it's a global variable that I set over here. So it will be equal to these values. Then translate factor.multiply scalar. We're going to be using our scaling factor then to multiply the scalar. Then we're going to say kObject.translate x equals to translate factor.x, kObject.translate y equals to translate factor.y, kObject.translate z equals to translate factor.z. kObject.get world position will be equal to tmp pause. kObject.get world quaternion will be equal to tmp quaternion or tmp quad. Let physics body equal to kObject.userData.physicsBody. Now this is the opposite to what we usually do in our update function, where we're updating the position of our meshes according to the position of the rigid body. Here we're doing the opposite. Okay, we're setting the position of the rigid body according to the position of our mesh. So we will also initiate a motion state. We'll say let ms equal to physics body.motion state dot get motion state. So then in here we're gonna check if ms is defined, and if it is, then we're gonna say mo tmp pause equals dot set value. If you're wondering what this is one of the global variables that we set, and what we actually need to do before I continue is set it to, I'll just need to do this. All right, so mo tmp pause equals to new mo.bt vector 3 and mo tmp quad equals to new mo.bt quaternion. So I need to do this also, otherwise I would have gotten an error, but it comes from these global variables over here. Okay, so let's go back to our move kinematic function. So we'll set the value of it to tmp pause.x, .y and .z. Then tmp quaternion, we'll set that to tmp quad.x, .y and .z or and .w. Then we'll set the identity of our TMP trans. We'll set the origin of our TMP trans, and we'll set the rotation of our TMP trans using these values. And then ms.set world transform equals to TMP trans. So now we've set the transform position of our. All right, now that that is done, I will come here and then let's see, move kinematic. And then I also need to create our kinematic box as well. Okay, to make this complete, I need to also come back to the key inputs, right? This is what I did inside handle key down. These were the key inputs for moving the ball. So just below there, these are the keys that will be driving the movement of our kinematic box. So you have them over here in our handle key down and also in handle key up. So everything is making sense now. All right, now we can have a look and see how everything looks. You refresh, zoom out. Okay, so now we have a scene with a ball that I can move and a square also that I can move. Okay. As you can see, I'm trying to act on the kinematic object, but nothing is happening. But if I do the same to the ball, it will move. So this is what the kinematic object does. So this can mess around with all these other guys, but not with the big block over here. So yeah, so overall, you've got everything going. I can still move this ball using the mouse input. I just need to zoom in a little bit so that it can be more visible. So far everything is working, and we've got a lot of different constraints. All right, so in a nutshell, today we covered constraints. We covered, well, the different types of constraints, which is a point-to-point constraint, a hinge constraint. We covered a slider constraint. We created mouse inputs or mouse interaction, so we're able to interact with the objects in our scene using our mouse. We also learned how to create a similar to what a character controller is. So we're using key inputs to move our rigid bodies around the scene. So we've actually covered quite a lot. So what we're going to do now is, for the next lesson, we're going to take everything that we have learned here and we are going to build something with it. Okay, so that's what's going to be coming up in the next lesson. We're going to create something cool using all of these different features. So if you are new to the channel and have not subscribed by now, now is the time to do so. Hit that like button. Make sure that you hit the notification bell so that you don't miss out on upcoming tutorials. This is it for this lesson. Thanks for tuning in. Till the next one, I'm out.